So we'll be starting on approximation. Actually, no. The more general term for that is differentials. It's just whenever I hear differentials, I always remember it's something that you use in order to approximate something that's not. It's realistically it's not possible when you mentally calculate for it in any other way. Maybe there is another way, but it's something that I'm not aware of just yet. So differentials, we have y is equal to f of x. We all know, I mean, something that you have to know is that delta y is y2 minus y1. This could be roughly the value of dy. dy is equal to the derivative of f of x times d of x. Sorry, dx. This is a formula that you have to know. So let's try a practice question. So find the derivative first. After finding the derivative, write dy and then place the derivative and then place dx. That's the answer already. Next. Okay, so this is gonna be, we'll save that for later. It's a long solution. So find the derivative first. This could be rewritten as so that's the final answer. I think we are ready to solve this question. Okay, so if you remember your inverse trig identities, the derivative of arctan is equal to 1 over 1 plus u squared times du over dx. What about for arcsine? That is equal to this. So 1 over 1 plus u squared times derivative of y over x. Since there are, this is an implicit differentiation problem at the same time. So x and then we are looking for dy over dx. How do I? Because I can't really assume yet because you might not understand it. In connection to what I've taught in the previous video, supposedly finding the derivative of y, it's going to be accompanied by multiplying dy over dx. But in the context of differentials, you just copy dy. You don't write dx anymore. So let's do exactly that. So copy the denominator and then derivative of the numerator. Derivative of y is 1 times dy. And then minus sign, copy the numerator, and then the derivative of the denominator, dx, coming from dx over dy. But you only write dx. Okay? And then below, this is going to be x squared. This is quotient rule, okay? Other side. And then derivative of 1 from the right side is 0. Let's further simplify. Okay. After doing this, you want to, for each term in the numerator, make it separated. Each has its own fraction. We can simplify this, by the way, as x squared plus y squared. And then you bring these together. So it's going to look something like, let's have dy first. X dy. Let's bring them close. So we transpose dx to the right side. And then following this format, so dy at the left side and then derivative and dx at the right side. So divide both sides by this, so this gets cancelled. We have this instead. And then division. So that's essentially it. This is the answer already. You want one more practice question that's related to that? I'm not gonna solve it one by one anymore. I'll just show you. So this is the other sample question. But that is partially correct according to some sources. You won't get full marks for that, definitely, if you followed that solution, but it's not completely wrong. That's what I'm saying. What about how about solving for this? So find the derivative first. So dy is equal to 1 over 3 cube root of x squared times dx. This is the final answer. Is it? Okay, that's it. Let's move on now to approximation. So whenever delta x is small, so delta y is equal to f of c plus delta x minus f of c is approximated using the derivative of f of c times delta x. So how do you apply that knowledge in equation form? So in other words, let's say delta y is approximately equal to dy, right? So y2 minus y1 is approximately equal to the derivative of f of x times d of x. So therefore, we can manipulate further this equation as y sub 2 approximately equal to y sub 1 plus derivative of f of x times dx. So this is the formula that you have to memorize for approximation. What are the steps on how to solve using approximation with the use of differentials? I don't think it's appropriate to teach it that way. Let's just go through the sampled problems already. So, square root of 4.6. First things first, we let y equal to the square root of x. And then, you find the derivative of the square root of x. So 1/2 x raised to 1/2 times 1. So from there, you whip out the formula. Now, you substitute. Oh, wait. Before you substitute your derivative, you have to start assuming what your y1 is, what your dx is, as well as your x sub 1. So, find a value that is close to the square root of 4.6. Let's say square root of 4. So that's going to be the value of our y1. If that is our y1, our x1 is whatever is inside. So it's 4. And our dx, it's basically so what you have in the actual given. So 4.6 minus the chosen value that is close to it. Therefore, you have 0.6 as your dx. Now, you substitute. y1 is square root of 4 plus the derivative 1 over 2 square root of, what is our x? 4. What is our dx? 0.6, or in other words, 3 over 5. Coming from 6 over 10. We just simplified. Now, further simplify. Square root of 4 is 2. 1 over 4 times 3 over 5. 3 over 20 plus 2. 20, 40. So, we get for y sub 2, 43 over 20. Or 2, 3 over 20. 2 point. You don't have to write a decimal anymore. These answers are already acceptable. So, if you look at your calculator, this value is very close to the value of square root of 4.6. That's basically the use of differentials for when you want to approximate the value of something, such as square root of something. So let's try involving trigonometric. So let's try arctangent of 1.5. So how do we do this? It really helps if you know your precalculus, particularly your unit circle, and for example, what the value of sine pi over 4 is. I know this is 45 degrees. Or this could be rewritten as, sine pi over 4 is, let's try something more familiar to me. Pi over 6. Pi over 6 is also 30 degrees. This is equal to 0. Is it? I think it's 1. I forgot it already, I think. Let me confirm though if it's correct. Oh, sorry. I remembered it in the wrong places. Let me show you the list. I'm supposed to show this sometime in the future, but I guess I'll just show it now. So, it really helps if you memorize that list. This paper is for the last lessons, more specifically solving limits using L'Hopital's rule. What else? Partial derivatives. Yeah. So yeah. Let's begin. So let y equal to arctan u. That's our first step. So find the derivative of this. 1 over 1 plus u squared times 1. This is a variable, so just u, its derivative is going to be just 1. So y2 approximately equal to y1 plus derivative times dx. Let's approximate what y1 could be. What's closest to 1.5? Let's try arctangent of 1. Therefore, our x1 is going to be 1. Our dx is going to be from 1.5 to 1, 0.5, or 1 half. So y2 is equal to arctan 1 plus there you go. But the question is, how would you approximate what this is? Actually, you don't have to. At least from my experience, you didn't have to. 2 times 2, 4. So this is the approximated value of arctan of 1.5. How about this? So exponential. Let y is equal to 3 raised to x. By the way, how do you know whether it's 3 or 2.9 that we want to approximate? What I mean by that is, how do you know if it's if you let y equal to 3 raised to x or y equal to x raised to 3? So just from there, if you get it wrong, your solution could be destroyed. You'd get it wrong in other parts. So it's, in this case, it's pretty obvious. It's 2.9 that you have to focus on. So we'll see if I'll be able to answer another problem that will help you understand the difference between this kind of case and the case in that question. So yeah, more on that later. So I believe we'll have to apply ln. So something that's unique with this question is, if you want to find the derivative of 3 raised to x, so of course you apply ln, but you're going to write it like this: 3 raised to x ln 3 times dx. Previously, coming from previous understanding, it's supposed to look like this. That's not the case for some reason. It's supposed to be this. So y sub 1 is, let's try 3 raised to 3. So something very close to this. x1 is 3. dx is, well, coming from 2.9 to 3, it's going to be 0.1. Negative. Y sub 2 is equal to y sub 1. 3 raised to 3 is 27. Plus derivative 3 raised to 3 ln 3. And then dx is negative 1 over 10. 27 plus 27 ln negative 2.7 ln 3. That's it. This is the final answer. y2, by the way, is, in other words, what's given. So it's not written like this, okay? It's written with an approximation sign, roughly equal to. not exactly equal to. How about a little more? How about this question? So let y equal to square root, no, not square, fourth root of x. So y1 is going to equal to, let's try 16. X1 is going to be 16. Your dx is therefore going to be 15 minus 16 equal to negative 1. So y2 is equal to y1. This could be rewritten as 2 raised to 4 or just 2 plus, oh, but sorry, you weren't able to find the derivative yet. Our x is 16 and then negative 1 for dx. Eight 32 for 832. Okay, 2 minus 1 over 32. 64 minus 63 over 32. That's the answer. Okay, let's try this. Sine of 30.85 degrees. How do we approximate this?